Hey, my name is Milan, and in today's video we're going to explore how to deploy a .NET and SignalR note-taking application into the cloud. We're going to use Heroku, who is also the sponsor of today's video, and I want to highlight their next-generation platform codenamed Fir, which makes it incredibly easy to deploy and scale .NET applications. We're also going to see how to introduce some Heroku add-ons for adding support for Redis and Postgres into our system, and we're going to take advantage of the native support that Fir has for OpenTelemetry to introduce monitoring and observability for our application. If you're not familiar with Heroku, it's a very popular cloud platform that allows you to easily deploy and run your applications in the cloud. What also makes it stand out is that it has support for many of the most popular programming languages, including .NET, which has recently become natively supported with a cloud-native build pack. Now, at the core of the Heroku platform, we have the so-called runtime, and until recently, you could use the classic runtime, which was codenamed Cedar, to power your application on Heroku, and this has been in use for many years. Now, there's also a new runtime which was just recently released, codenamed Fir, and it represents the next generation of the Heroku platform. So why is the Fir runtime so powerful? Well, first of all, the main driver behind Fir is cloud native support. I already mentioned cloud native build packs, which allow you to take your application, let's say a .NET application like we are going to use, and turn it into an OCI-compliant image that you can run inside of a container. The Fir platform also makes it easier to scale your application, it's faster, and it gives you many more options when it comes to the resources that you want to allocate to your application running in the Heroku cloud. And one more key thing that I'm very excited to showcase is the native support for OpenTelemetry. OpenTelemetry is a standard for how you can generate, collect, and export your application's telemetry data. This includes metrics, traces, and logs, and this helps you analyze your application's performance and behavior. Now, the Heroku Fir runtime natively supports OpenTelemetry, which means it's going to automatically collect your telemetry data, and it gives you a simple way to export this telemetry data into some sink that can process it. For example, we're going to use Grafana as part of this video. Now, how you do this is you configure your Grafana resource, which gives you an endpoint where you can export your telemetry data, and all you have to do is run a simple command using the Heroku CLI to introduce a so-called drain, which is going to connect your Heroku application to the telemetry sink, and then Heroku is going to automatically export your telemetry data. Now, let's take a look at the application that we're going to use for this demo. So what I have here is a .NET 9 note-taking application which integrates with SignalR to allow us to update our notes in real time from multiple clients. I'm going to show you what this looks like when we run the application, but first let's take a brief look through the source code to help you understand how the application actually works. I'll start from the program file where we are first fetching an environment variable, and the name of this environment variable is Redis URL, and this is a value that is automatically configured by Heroku when you introduce the Heroku key value add-on. I'm going to show you what this looks like a bit later in this video. Now let's say we grab this environment variable, and if it's not null or empty, we're going to parse the host and the port for a Redis resource and use that to configure SignalR along with the Redis backplane. And why this is so powerful is because SignalR by default only works in memory. And when you scale out your application, you're going to have multiple SignalR hubs that have different states stored inside of them. By introducing a Redis backplane, you can have your application use Redis for storing the connection information, and it won't matter how many application instances you have, they are all going to use the same backplane for SignalR. Now, of course, if the Redis URL is null or empty, we're going to just fall back to using the plain SignalR service that works in memory. You're going to see a similar approach here, where we are fetching the database URL environment variable, and we want to use this to connect our EF core database context to Postgres by saying use mpg-SQL and providing a connection string value. And of course, if this value is null or empty, we're going to have a fallback, which is going to use SQLite if Postgres isn't configured. This is also going to come in handy when we want to run this application locally. Now, a couple of more things we have is introducing Razor Pages, because we also have a client-side component. And then the rest of this is a pretty basic setup for a .NET application. One notable thing is exposing our SignalR hub, so let's take a look at that next. I'll open up the Node hub. And what you can see here is we're inheriting from the hub base class. This is how you define a hub with SignalR, and this allows you to expose functionality that the clients can call on the SignalR server. Now, I'm also using a database context to make sure that we persist the nodes inside of our application. And you can see that when a client first connects, which is the onConnected async method, we're going to fetch all of the nodes from the database, and then we're going to stream the nodes one by one to the connected client. This is going to allow us to render all of the nodes for a new client when they've just connected to our application. And then we have functionality for adding a node, updating a node, deleting a node, or moving a node, and all of this is backed by the node model. So let's take a look at that next. And you can see it's fairly simple. We're storing a title and the content of our node. We can also color code our nodes, and the default one is going to be yellow. And then we have the position on the X and Y axis, which is where we're going to render this node on the screen. Our database context is just a simple EF core database context that configures some basic options for the node entity. And finally, let me show you the home screen, which is a Razor component. This is the backing class, and what we're interested is the HTML part, or the CS-HTML to be more precise, which is going to configure the SignalR connection. Let me go to that part of the code. So you can see here, we're using the client-side SignalR library to initialize a SignalR connection, connect to our SignalR hub, and then we're going to configure what happens when we receive a specific event from the server. So you can see we have a callback on the receive node, update node, delete node, and the move node method. And finally, we're going to start the connection. Now, what's also interesting is that we can call the SignalR server from the client, which you can see in this example here. When we create a new node, then we need to notify any connected clients that they should update the state on their client interfaces. So here we're creating a new node with some default values, and then we can use our SignalR connection to invoke the add node method on the hub, and we can even pass it a JSON object. Now let's run this application locally to see how it actually works. And I'm going to say .NET run and specify the path to my project file, and then this is going to build and start my application. So you can see we have a log here that the Redis URL and the database URL are not found. So we're going to fall back to in-memory SignalR and SQLite instead of using the Redis backplane and Postgres. Now our application should be available on this port locally. So let me open this up. And when I navigate to this address, I'm greeted by my client application, which is our SignalR real-time sticky notes application. Now what I did here is open up two browser windows so that I have two client application instances. And when I click the plus button here, you're going to see a note show up in both of our clients. And this is all powered by SignalR behind the scenes, which allows us to implement real-time communication between our clients. So if I were to update this node, it's going to store this value inside of my database and then propagate the update to my connected clients. If I were to add another node, it's also going to show up in my second client. And note that when I drag the node on the screen, it's also going to propagate this change to any connected clients. Now, if I were to go to this address again and open up a new browser, you're going to see that it loads with all of the existing sticky notes that we previously added. And if I were to delete them from another client application, this is also going to be communicated to any connected clients. So this is how our application works locally. But we are interested in running this in production on the Heroku cloud. So we have a couple of options for how we can deploy our application into Heroku, and one prerequisite is having a proc file defined in the root folder of our application, and this tells Heroku how to start our application. So you can see this command here, which is going to navigate to the publish folder where we have our executable, and is going to run the Notepad app, which is our application, using the port environment variable, which is configured by Heroku automatically. So with the proc file defined like this, we can deploy into Heroku. And one of the options is using the Heroku VS Code extension, which is probably the simplest approach. And all you have to do is click deploy to Heroku. If you aren't logged in to the Heroku CLI, it's first going to prompt you to log in. And after you do that, your GitHub repository containing the application is going to show up. So I'm going to click deploy to Heroku, and then I can give my application a name, define who the owner is, and optionally define a private space for my application. The second approach is going through the Heroku CLI, where I can also create my application just the same like this and configure the application name and space. But I want to show you what the flow looks like with Heroku Fir from the Heroku dashboard. So let's go over there. Everything starts from creating a private space on Heroku. So the first thing we have to do is assign a unique name to our private space, and I'm going to call it Notepad App Demo. I'm going to leave the space owner as the default value, and I want to choose the third generation of the Heroku platform for this private space. This will allow me to create third generation applications later on. I'll leave the region as Virginia, United States. I'll use standard isolation, and now I can go ahead and create my space. And what you'll notice is that this is pretty much instant compared to Cedar, which may take a couple of moments to provision the private space. So from here, I can go ahead and create my new application, and you can see all of the supported languages that we have here, including .NET. So let me go ahead and click Create New App. I have to define a name for my application, and I'm going to say Heroku Notepad App. And after I click Create App, it's going to be created inside of the private space that we defined in the previous step. So let's go ahead and create our application. And this is going to land on the deployment screen, giving me a couple of suggestions for how I can get my application deployed into Heroku. Now, the approach I want to show you is using the Heroku CLI, where all you need to do is run a few simple commands to deploy your application into Heroku. So the first thing you have to do is define a Git repository, which I already did behind the scenes. And now what I have to do is to define a Heroku Git remote, which is going to point to my Fir platform application. So I'm going to copy this command here and go back to VS Code. And let's go ahead and run this command to introduce our Heroku remote, which is going to set the Git remote to this URI, which is hosted on Heroku. Now let's go back to the Heroku dashboard, and you can see that the next step is just staging your files, making a git commit, and then this is the key step. We're going to push our main branch into the Heroku remote. So I'm going to copy this command and I'm going to paste it in my terminal and run it. And this is going to kick off my deployment to Heroku. So this is how easy it is to deploy a .NET application into the Heroku cloud. Now this is going to take a couple of moments. It's going to figure out what our application is in terms of the technology stack that it's using, and it can automatically detect that we are using .NET. So it's going to default to using the .NET Cloud Native build pack to build our application and then be able to run it inside of Heroku. So you can see the output in the console here that it's using the Heroku .NET build pack, and it's going to target the .NET 9 SDK to build and run our application. Then it's also going to detect our prog file, which we configured in the root folder of our application. And just a reminder, this is how we tell Heroku which command to use to run our application. So after this completes, and it was pretty fast, you can see our application is live on Heroku on this address. So if I navigate here, you can see our note-taking application running in the Heroku cloud. So we can do all the same functionality as before, like adding a note, updating the note title and the content of this note, and this is going to be propagated to all of the connected clients using SignalR. However, the problem is that we are still using the in-memory SignalR server and the SQLite database. So let's see how we can improve this. If I go back to my application on the Heroku dashboard, you can see our application's resource, which is called a Dyno on Heroku. Now, what's really cool here is that you can configure your Heroku instance. For example, I can configure how many instances of this application I want to run, and I can scale all the way up to 255, and you can take this even further if you reach out to support if you really need that many application instances. So I'm going to leave this to 1. Now, another interesting thing is that you can configure the resources for your Dyno. So I'm currently running on 1 CPU instance and half a gigabyte of RAM. So I can scale this up to 2 CPU instances and 1 gigabyte of RAM, or I can add more RAM if that's necessary. And below you'll see an estimate for how much this will cost. And if you're happy with this, you can go ahead and update your Dyno. Now I won't be doing anything, and I'm just going to leave the values that I already have in place. I just wanted to highlight how the Fir platform makes it much easier to scale your application. Now, one more thing that Heroku has is support for Heroku Add-Ons. If I go to the Heroku Add-Ons page, you can see a list of all of the supported add-ons. You can also filter them based on the platform generation that we are running. So because we are using Fir, let's take a look at the add-ons that are supported for the Fir platform. And the one that we are going to need is the Heroku Postgres add-on. There's also an Apache Kafka on Heroku that you can easily add to your application. And there's also a native key value store. So I'm going to close this down, and let's go back to our application's resources, and here you can scan for add-on services. So if I look for Postgres, I can choose the Heroku Postgres add-on, and here I can pick the size of the instance that I want to run, and I'm just going to run the simple Essential Zero add-on, which comes out to about $5 per month, and I'm going to submit my order form, and this is just going to start provisioning my Heroku Postgres instance. Let's do the same for Redis. Now you have to look for Heroku Key Value Store, so let's choose this, and the same as before, you can choose which plan you want to run. I'm going to use the smallest plan, which costs about $3 per month. So let's go ahead and provision this. this. And once these add-ons are provisioned, Heroku is going to automatically configure the respective environment variables for the Redis URL and the database URL, and our application will be able to connect to these resources. So this is going to take a couple of moments. Now, if you want to learn more about the next generation of the Heroku platform codenamed Fir, click the link that's going to be in the pinned comment under this video to visit Heroku's website and learn more about Heroku Fir. Now, going back to our demo, while our resources are being provisioned, I want to jump back to VS Code to demonstrate that once we deploy our application to Heroku, the Heroku extension for VS Code is going to pick up on this and is going to detect and show our Heroku application. I can also synchronize this with Heroku, and it's also going to pick up on my two add-ons that we are currently provisioning. And you can see that the Heroku Postgres add-on has been provisioned, while the Redis add-on is still provisioning. You can also see our resource and the compute that's available to it. And then this is our Dyno instance, which represents our running application. Now let's talk about OpenTelemetry. So Heroku, with the third generation, natively supports OpenTelemetry. And the key concept that you have to understand here is telemetry drains, which allow you to configure a URI where your telemetry data is going to be exported. Now you can configure this on the space level, and then all of the applications inside of a given space are going to have their telemetry data exported to this URI, or you can configure specific telemetry drains for each of your application instances. Now in this case, the drains are going to stack. So if you have one drain for your application and another for your space, they are both going to be applied. So let's see how we can configure a telemetry drain with Heroku. I'm going to configure mine on the space level. So I'll open up a console instance and I'm going to say Heroku telemetry and then pass in my space name. And then this is going to tell me that I currently don't have any drains configured for this particular space. So how can I solve this? Well, I first need somewhere where I can export my telemetry data, and I'm going to use Grafana for this. Grafana is a very popular observability platform that also integrates with OpenTelemetry, so we can export our traces, metrics, and logs into Grafana and be able to monitor and observe our application's behavior. It also comes with an excellent free tier that we're going to use for this demo. So if you create your account and head into Grafana, you should be able to obtain an OpenTelemetry endpoint where you can export your telemetry data. So this is the endpoint here. You can also generate an API token, and this is going to give you a set of environment variables that you can use to connect to Grafana. One of the key pieces that this is going to give you is an authorization header value that you're going to pass in with your telemetry data. I already created this, so let's go back to the console, and then this is the command that I'm going to run. I'm going to say Heroku telemetry add, and then specify my OpenTelemetry endpoint. I'll pass in the name of my Heroku space, which is Notepad app demo. I can also filter the specific signals that I want to emit with my telemetry. By default is going to be traces, logs, and metrics, but you can also export just one of these. You can also configure multiple drains for each of the signal. For the transport mechanism, I'm going to use HTTP, and then I have to specify my authorization header value. So once I run this command, we should get a message that a drain has successfully been added to our space. So now I can rerun Heroku telemetry, and you can see that we indeed have one space configured. So now we're going to automatically export telemetry data from our Heroku application instance into Grafana. So let's see if this is actually working as expected. I have my Grafana dashboard on the left here and my application on the right. So if I go ahead and do something inside of my application, such as adding some nodes, updating some nodes, moving them around, adding another node, for example, and then deleting a couple of these nodes, you can see that our logs are constantly being updated in the Grafana dashboard. I can also look at more specific logs, let's say from the Heroku Notepad app, which contains the logs from my application. So you can see EF core logs here executing a delete command on our database. What's also cool is that we are getting telemetry from Heroku Redis, which is the add-on that we configured, and also the Heroku router, which contains some information about the SignalR messages that we are sending. Now, apart from the logs that Heroku is going to automatically export to our drain, we're also going to get some application metrics. So if I go into metrics and explore what we have here, you can see some useful information about CPU usage, memory usage, and information about your container instance that's running on Heroku. Now, another thing that's supported is application level instrumentation. So let's go back to our application and I'll show you what this looks like. Because Fir natively supports OpenTelemetry, we can also configure automatic OpenTelemetry instrumentation inside of our .NET application. If you aren't familiar with this, we have to install a couple of NuGet packages. Let me highlight the most important ones, which is the OpenTelemetry Exporter, OpenTelemetry Protocol, OpenTelemetry Extensions Hosting, which is going to run a background job that's going to actually export your telemetry data. And then we have some automatic instrumentation for ASP.NET Core, HTTP, Runtime, Stack Exchange, Redis. There's also the MPG-SQL OpenTelemetry package, and you can use all of these to introduce automatic instrumentation into your .NET application. So how you configure this is you can say add OpenTelemetry, configure your resource name. I'm calling it the Notepad app. I can also add this as a source, and this is how you configure the instrumentation libraries. I'm also introducing the SignalR client and server telemetry data. Then we're wiring up MPG-SQL, and finally we are configuring an OpenTelemetry exporter. Now what's interesting here is that I can export my telemetry data to this address available on localhost, and this is actually going to be an OpenTelemetry collector running inside of Heroku, where I can stream the telemetry data from my .NET application, and then Heroku takes care of sending that telemetry data to any drain that I have configured. In our case, this is going to be sent to Grafana. Now, apart from the automatic instrumentation, you can also introduce manual instrumentation. For example, like what I added inside of my SignalR hub. Let's say when we call the add note method, I can add some log statements, but I can also start an activity which is going to generate some tracing data, and I'm giving my activity my name so I can identify it inside of my traces dashboard. So now we just need to deploy our application to Heroku and generate some activity to produce telemetry data, and then we're going to jump into the Grafana dashboard. So now if I go back to the Grafana dashboard and I take a look at the traces screen, I can see my application traces are now being streamed to Grafana, where I can take a look at them. For example, we can dig into this specific trace and take a look at what we have inside and what's going on inside of this trace. So this is how you can configure OpenTelemetry instrumentation in your .NET application and have it exported by Heroku into a drain that you configured. In our case, this is going to be Grafana. You can see I generated about 200 something traces in a fairly short amount of time, and we even get some metrics here in terms of the span rate and the duration of our traces. And I'm blown away by how easy it was to configure all of this, because now we have some pretty serious observability information for our system, thanks to native support for OpenTelemetry in Heroku, which also exposes logs and metrics, and we have the simple ability to export our application telemetry into a local telemetry collector, and then export that into any of our configured telemetry drains. If you enjoyed this video, make sure to smash the like button. Also, go ahead and click the link that's going to be in the pinned comment right under this video to visit Heroku's website and learn more about the next generation of the Heroku platform codenamed Fir. Thanks a lot for watching this video, and until next time, stay awesome.